welcome to our talk, Get to Know Your Application, a never-ending performance testing story. So before going to the topic, let's introduce quickly ourselves. So I am Philippe Vincent. I'm a senior software engineer working in Switzerland since 5 years. I'm part of the FS Acquiring Processing Front Office EP2 team, and since 18 months, I am focusing on performance testing on our HA EP2 platform. I'm also part of the tech squad as I'm the co-leader of server dev, performance, and data squad.
And my name is Dylan Shepherd. I'm an application engineer. I've been working a little over 2 years, that's wrong, in testing and QA in the TCC, Testing Competence Center in Belgium. And Philippe and I started working together about a year ago in the Marco Polo project, which is the project in Australia. And now we can go on to the next. So since the main topic of our conversation is, of our talk is performance testing and quality assurance in general, it's important to give a definition of what this is to us anyway, because there's loads of definitions out there. So performance testing is about the overall quality and robustness of your target systems and applications by simulating real-life production scenarios using various tools and in a dedicated test environment. So we create the test environment by first looking at the production setup and then replicating the software and hardware as close as possible. And we'll give an example of how we did this later for the Brexit project. But in essence, performance testing is about assessing the end-to-end and overall performance of one or more applications under realistic conditions and loads. So we begin the process by creating a test plan, executing it, then analyzing the results and sharing them to the relevant stakeholders in an organized and understandable manner. So it's different to functional testing, which should come beforehand. It's a different idea. It's really the overall end-to-end. You want to look at the bigger picture here. And so we're still a bit general, but we'll give another definition of that we use often, which is robustness testing. And robustness testing, we follow the same methodology as with performance testing, but we intentionally sabotage the environment. Why? Because on production we see this as well. We get data centers which might go down, HSMs that break, etc. So you can think of it as this car. It's got 4 wheels. If one of the wheels falls off or breaks or has a puncture, you don't expect the steering wheel to stop working. So that's what we're testing for here. We sabotage parts of the environment, and we expect that the overall performance isn't too affected. Now, as I was talking about earlier, creating the testing environment, we first look at the production environment, and there's a lot going on. You shouldn't have to try to understand that. I don't. But there's lots of applications, interfaces, etc. And we want to take the most important parts. So here, the FO, namely, and already we can go ahead. Okay. Here's the performance environment that we created, and okay, a lot of it is gone, but the important parts, the FO, the DBs, HSMs, etc., they remain exactly the same in terms of software and hardware, which gives us the ability to start our tests. And okay, now we know a bit what performance testing is. Why is it important?
Okay, so why is performance testing important? Performance testing will not, you will not have new customer thanks to it, but you will keep the trust of your existing customer. So to illustrate this, let's take an example. So in the US, Ticketmaster is the only company allowed to sell to retail concert tickets. And in 2022, there was a Taylor Swift ticket sale, and there was a huge outage. And so lots of fans were not happy about it. They complained a lot on social media, which put lots of media exposure on Ticketmaster. And 1 year later, there were even a Congress hearing about the Ticketmaster Taylor Swift performance outage. And 1 year later, so this year, the US Department of Justice is suing Ticketmaster. So the performance problem is of course not the reason of the suing, it's for antitrust. But still, it put lots of mediatic pressure on it. And I'm quite sure they would have avoided this. So in my opinion, it's a really good example of bad consequences due to performance problems. So obviously, you should do performance testing. Then, how to do it? So this is where science comes to the rescue. In fact, we are lucky because both performance testing and science, they share some common ground, which is illustrated by this quote from Albert Einstein. So in theory and practice are the same. In practice, they are not. What does it mean? This means that the observation of the world around us is really important to understand the world. And this is exactly what Dylan said about the performance environment. So it definitely makes sense to use the scientific method in order to do some performance testing. But what is the scientific method? So here's a novelly complicated explanation generated by ChatGPT, but I'd rather explain you in a few steps. So the first one, you have to define your question. What do you want to know about your application? Pick your hypothesis. The second step is to design an experiment, a protocol that will give you data. Then you will analyze the data. And last but not least, you will present your result. This is the scientific method. Before showing you how we applied this scientific method, there is a few, unfortunately, sorry for this, there is a few projects and acronyms that we need to explain you. So it will be more interesting for you once we explain this. So EP2. EP2 is the leading Swiss payment protocol. Initially, it was created in Switzerland, and now it's present in 30 countries, and it's implemented only by Worldline, as far as I know. The EP2 HA platform is the Swiss platform that is handling all those EP2 transactions, and WPFO means Worldline Pay Front Office. It's another payment processing platform that doesn't do EP2.
And now ACQ-AU, confusingly, is also called sometimes the WPFO, and is part of the Marco Polo project, which we spoke about earlier. And all of these as well are part of TAP, the Target Acquiring Platform. And it's more of a vision and future idea of having the same sort of setups in terms of implementation and hardware. And that's what we have to say about those terms, but people will still get confused about them. But what can we do? Now, to go on, we're going to talk about a specific payment protocol, which previously was untested. We didn't have a means of performance testing it, and that's Nexo. But anyway, since it was untested, I was tasked with starting the performance test for it. So I had to see, okay, first, the good idea is to look at production. And I saw the data there, 60% of transactions were e-com of a specific transaction type. And they were all from A hub, the acquirer hub, to the front office. So that's what I chose. And since we started testing it, we've increased the efficiency of the WPFO to handle Nexo transactions by 400%. So it's just an example of the use of, of performance testing. And now a more complicated protocol, which Philippe will talk about, is EP2.
Okay, EP2, so this is a very simplified view of the EP2 platform we have in Europe. By the way, if you like the topic and the show today, I have a presentation tomorrow about EP2 platform, so feel free to come tomorrow. About the EP2 platform, so you have a front office in red, terminal front office, which is made of two platforms. You have a NS Legacy at the bottom in green, and you have a HA platform in blue. So let's focus on the legacy platform. You have a small box called services, which is in fact every services deployed on this application. I think it should be several hundreds. But yes, it's just one box to keep it simple. When we look at the HA platform, we have a free message flow of EP2, init, online, and batch. On the right, we have a transaction processor, which is protocol agnostic, which means it doesn't handle only EP2, it does other protocol. And let's see what happens when a terminal sends a message. So terminal sends a message on the left. The first application to receive a message will be the EP2 proxy. The only purpose of EP2 proxy is to route the message toward the legacy platform or toward the HA platform. And then business logic will happen. But anyway, whichever platform it goes on, the business log will be handled in the legacy platform that will call the acquiring front office. Acquiring front office will call the acquiring back office, and then this is back office business, so none of my business, definitely. Now, Marco Polo. So remember, we explained quickly, there is a new box called WPFO. The link between the HA platform and WPFO is the strap interface, which is implemented in the transaction processor. And as it is in Australia, there is no legacy. So all the bottom part is gone. And if all the bottom part is gone, you don't need a EP2 proxy. And this is the architecture we have for Marco Polo. And as Dylan explained before, This is also a conceptual view of a TAP architecture, target acquiring platform. So in Europe, I know it could be a bit confusing, but now I think you got everything. Now you got everything you need, and we can really dig into the topics. How did we apply the scientific method to do performance testing? So remember what is the first step? The first step is decide what you want to know about your application. Pick a question. So what does performance means to you? If you ask, let's say 5%, 5 different persons, there is a good chance that you will get 5 different answers. And the most usual answer will be this. Some people will say, oh, how many TPS can we handle, or maybe request per second? What is our mean response time? Are we within our SLA? Because if we respect our SLA, we should be good, I hope. That's the point of the SLA. Some people will go more in the robustness area and say, oh, what if our platform receives way more traffic than expected? What will happen? Will it explode? Will it not? And or what happens if there is an outage, even internally, or maybe a third-party services that you are calling have an outage? What happens to our platform? And all those topics are, let's say, good topics in terms of performance testing. So how, as someone which is responsible of doing performance testing, how do I handle it? In fact, I need to get to an agreement with the stakeholders, and even more difficult, between the stakeholders. When you start performance testing campaign, everyone should agree on what the objectives are, because if you don't pay attention to it, everyone will want something different, and in the end, you will be confused and you won't have any answer. So it's important to put everything in wording and to get an agreement.
And yeah, as he said, it's difficult to know, but the point is it's important to have some goals, expectations before you go into tests. You can't just randomly execute stuff without a clear idea. And these expectations and preconditions, they should be based on real data and metrics, because you're going to have to prove it later. But a good one to start with that most people are familiar with is transactions per second. So you can look at prod again and try to say, okay, the average transactions per day is this amount. And then you send that to the FO or wherever you may have. But that's not enough, because what happens if you reach you're able to reach the limit, but other things aren't good, such as CPU usage, RAM usages. All of these need to be taken into account if you're trying to prove the performance and quality of a system. And then you get even more questions which are useful for the future. Do the apps scale well? If you double the amount of hardware, will you get double the performance? It's not always the case, but it's worth to find out. And then in performance tests, sometimes there are going to be things on production that are hard to take into account, like third-party services, namely schemes. And we are able to mock these somewhat realistically, but not always perfectly. But it's something to take into account as well, and something you should try and mimic in your performance environment. And so to do with metrics and real data, now we'll show you some examples of ones we use regularly across environments, protocols, etc. As I spoke of earlier, the transactions per second, and displayed quite nicely in a dashboard like this. You want it easy to read. Simple is nice. You don't want to be explaining the same data to different people again and again. So this is simple to read. Y-axis, transactions per second over time. Most people can get that, and it looks nice as well. And more examples here of how to display data and metrics in an understandable manner. And these are all as well ones we've included in reports. And you want to come away with a final conclusion at the end of the day, pass or fail. That's the point of the test. So there you have. It's the takeaway here is that it's all real data and it's simple to understand. So now we have ideas of how to collect data, what we're looking for, and we have a performance test environment. How are we going to execute the tests? You need a simulator tool. And we have been using CAFI, which is a tool that was developed in Switzerland. And it can be thought of as not only, but it emulates a population of terminals, which will send messages or transactions to wherever you point it to. And the nice thing about it, it's multi-protocol. We've been using it currently for EP2 and Nexo, and we have more in the works, and it's always being developed. It's able to generate gather data and send it to multiple places, namely Kibana, where we got some of the dashboards before. And it can also generate very quickly all the images you saw in a matter of seconds. And these used to be difficult to take. We had to query DBs, manually scrape through logs, but now it does it in a matter of seconds. And of course, it's entirely Java, so that means you can run it anywhere. It's not a problem of OSs. As long as there's a JVM, write once, run anywhere, right? And it's highly configurable. It's not limited only to being a transaction simulator. You can also, as I said, it sends logs, it's scalable. We're developing it constantly. We're adding new protocol support, and it looks good for the future. But it's something to take into account is which simulator tool you pick and do you want to use. Now, sorry. Yeah, the next question is how are we going to handle and take care of our test environment?
Okay, so it's another dimension when you think about your protocol. So we are step 2, designing your protocol. You need to think about the boundary of your system because let's say, because what you want to test is your system, not a third party. So there is a good chance that you need to isolate the system that you are testing from the third party. So this is why you need to define mock. And there is several motivations. The first one is exactly what I said, to not flow your results. You are testing your system and not your system and the third parties. And there is a good chance that if you don't do so, that you will kill the other services because you will run on dedicated performance environment, if you are lucky. And there is a good chance that the third-party services are not properly dimensioned. So if you don't pay attention to this, there is a good chance you will kill some services, and last point, some people will not be very happy. So if you don't do so, there is a good chance that your application ends in the swamp of sadness, exactly like in the movie. And the other side of the coin is you have to, okay, it's great to put a mock, but you have to configure it correctly because let's say the performance on your mock is worse than the performance from your application, then the mock is your bottleneck, and then you have no result. Great, you tested wire mock. Congratulations. Another dimension again is getting the support you need because there is no way that you can do a whole performance testing campaign without asking for help. It's impossible. So you have to be ready to call for help, and because you can know everything. So best way is to be prepared and to identify people beforehand. So what kind of people do you need? You need technical people such as software engineers, developers, but you will also need some network engineers or DBA. You need all those kind of people. If something happens, then you know what to ask. You will need business people as well, like a business engineer or testers, because they are testing the application quite often. They know very well the business, and if something strange happens, maybe they already made the case, so it's always good to have them not very far away. And last but not least, managers. I know what you're thinking, why do we need managers? So, because when you will ask for some support to technical people and business people, there is a good chance they don't know you and they will not have, let's say, helping you will not be their priority, definitely, if they have something else to work on. So having managers and stakeholders in the loop, it can help you to clarify those priorities and get the support you need. In Australia, for Marco Polo, we had weekly meetings with some managers and stakeholders, and it was very effective. Okay, so your protocol is ready, you have everything, you know how to load your system, how to observe it, and everything is fine, so now this is the D-Day. Let's run those tests. So, what are those points of attention during the run? So, first I'm talking about a D-Day, because you have to keep a time slot as short as possible, because let's say you wait, then there is and the more you wait, the bigger the risk, someone will disturb your system. And if someone disturbs your system, then you can throw away your result because you cannot compare apple to oranges, definitely. So that's why you need to keep it in a short time frame as much as possible. Another aspect is communication. So for two reasons. You need to inform everyone that has some link to the platform you are testing that you are doing performance testing, because else maybe they will notice some strange behavior, of course, because you are not testing, and they will spend time investigating. And so just keep them updated is definitely easier. And it works the other way around also. For example, in Europe, we don't have any performance dedicated environment. I use PPD. And PPD is a step in our Jenkins pipeline. So when I do performance testing in Europe, I say, please don't deploy on PPD, else you will wipe all my setup, or at least ping me. It will be nice. So definitely don't oversee communication. It's very important. Now you've got all the data you need. So next step, how to extract the gold nuggets.
So yeah, you've run your tests, and we're reaching the second last step of the scientific method here, which is data analysis. You've got loads of data, you've got loads of results. You need to think, what are the important ones to look at? And whatever you choose, you have to be able to support it and back it up with proof and evidence. That's what all the data is for. And finally, they have to be conclusive and easy to reach, easy to understand, as I said earlier. And you want to avoid technical jargon and confusing people. You might sound smart, but nobody will understand what you're talking about. So just keep it simple. And finally, you want to come away with a conclusion, pass or fail. And that's where we go on to the next part, which is really showing how to present your results.
Okay, in order to illustrate this, okay, I'm sorry it's in French, but it's a French quote. But basically, you can translate it is something that is well understood, is easy to explain. And this is where the scientific method will really help you, because if you have, exactly like Dylan said in previous slide, if you have a result like this, synthetic, conclusive, exhaustive, all those things, then it will be very easy to present it. I mean, use number, use simple sentences, and use charts, and it should be okay. Okay, so in our case, for our different performance testing campaign, how did we do it? First, we documented everything. We picked Confluence, because it never moved, unless Confluence is moved to Confluence solution, of course. I guess we all have been in this situation. So yes, everything is documented in Confluence because it's easy to share, and an email thread, I mean, come on, it's not a way to document. And we use a lot of PDF reports that are generated from Café Artifact. It's a really fast way to get some result and that you can send to someone and they really understand what was done and what was the result. And last but not least, part of our job is advocacy. And so we made several talks to the team, a bit like what we are doing today. So this is how we handle the result presentation. Okay, now we are reaching almost the end of the presentation. What kind of result did we find? Remember, those are the 4 questions we talked about when we defined what do we want to know about system. Now you have a result. So in terms of TPS for EP2, it depends a bit on the chain, but we can reach per node around 150 transactions to 250 transactions. In production, we have between 8 or 9 nodes. It depends on Europe and Australia. But still, we have a very good knowledge about it. Resource consumption, everything's fine, no CPU memory explosion, and it makes sense because the limitation of the traffic is done via an internal thread pool, and so we know exactly the impacting parameters, so it's very interesting. In terms of capacity planning, the scale is almost perfect. You double the resource, you've got twice the TPS, it's great. And what happens is third-party services is very slow. Again, it's a number per node. We're going to have 360 transactions living in the system. Any additional traffic will be properly refused, which means the load will not stack up in your platform. And this is really important because this is definitely going to kill you at some point if the load is just stacking up. So those were our results, and I think now we can talk about the future.
Yeah, so we worked together, as I said, on Marco Polo, and we learned a lot there of what to do and what not to do. And one of the things that we're going to do in the future as well is continue to work on more projects, Brexit and Este. So you're stuck with me for a while, Philippe. And one of them, one of our plans, though, is to keep developing, as I said, the tool we're using. It's always being improved, and we're adding new features onto it all the time, which is saving us a lot of time in terms of like automation. And so that's something we're definitely going to stick to. Philippe and I both know how to use the tool and also code and develop it better. And another one is better communication. So this is what you want to avoid. I was told of a change request at the last second, and it was going on for months in a conversation, but I was never included in it. So I blocked it for a while, and it was only delayed by a week, and it turned out not to be a mistake. But had I known earlier, we could have avoided that. But it's just an example of that you want to communicate as much as possible with all the stakeholders, have everyone involved and in the loop. Otherwise, you can waste some time. And we can finish it up now with the takeaways.
Yes, this is really the end of the presentation this time, so take away. Two things. First thing is performance testing is really, for me, an engineer job. Okay, you will need technical skills, but not only you will need technical skill to understand your system, set up your environment, and then understand the result, great. But you will need also analytical skills, because you will need to find a way to visualize correctly your data in order to present the results. And if something goes wrong, you need to find an explanation, of course. You cannot say, oh, yes, oh, I can tell you that I'm sure that our system can handle between 20 and 100 transactions per second. Great, what do I do with this? So definitely analytical skill. And last but not least, communication skills, because at the end of the day, the important thing is that you can provide the result to the stakeholders. Else, all that you did before is not really important, in my opinion. So don't oversee the communication skills. And a good way, second takeaway, a good way to reach the end of a performance testing campaign, because usually it takes months, I would say, I guess. Usually it takes some months for us, and we are used to it. Okay, few steps to follow. Define your question. What do you want to know about your system? Once you know it, design a test protocol, then run it. You will have some data. So analyze your data, find the gold nuggets, and then present the results so everyone knows what you did, and everyone is happy at the end. So thank you for your attention. This is the end of our presentation. I hope that you like it. And